3D trigonometry. You're going to want to save this video to help you prepare for your calculator paper. Okay, so what does it say? It says ABCDEFGH is a cuboid, AB is 40, BC is 9, CG is 20, and AP is 25, which they decided not to put on the diagram. That was not intentional from me. It was actually in the question I found, they didn't actually label it. It says the ratio of HP to PG is 3:7. Okay. Work out the angle APC. Okay, so before we make a mess of the diagram, I always recommend to you guys, when it comes to 3D trig, redraw the triangle somewhere else, all right? So that you can mess up the diagram if you want, but at least you have the triangle written somewhere else as well. So let's just do our triangle. It looks something like this. And at least from here, we can figure out what lengths we have and what lengths we need. Okay, it's very important we make a plan here. Now we already have this as 25, and we're trying to work out this angle. Let's call it feta cheese. All right, we're gonna need more lengths. Okay, so non-right angled triangle. So I'm already thinking about the sine rule and the cosine rule and half AB sine C. Okay, half AB sine C obviously not, because we're not trying to work out an area here. So we need to work out other lengths. How are we gonna do that? 3:7 means that potentially, well, most likely these lengths are going to be important to us. Okay, how do we work out those lengths? Well, because it's a cuboid, this length, HG, is the exact same as AB. Okay, so these two are the same, which means that if this cuts the ratio 3:7, we can use 40 to work out these lengths. So we do 3 plus 7 is 10 parts. And we do 40 divided by 10, which is 4. Okay, so 1 part is worth 4. Yeah, if 10 parts are worth 40. So 3 parts is 12. So this here is 12. And 7 parts is 28. Okay, where that's useful we'll see in a bit. Now I can work out AC really easily. Because this is a cuboid, we have a rectangle on the base. So if we redraw that rectangle, it looks something like this. Yeah, that base rectangle, ADCB. ADCB. And we're trying to work out AC. So you can see here we have a right angled triangle, 40 and 9. And we can easily work out AC. By doing what? Pythagoras. AC squared is 40 squared plus 9 squared. And then we might as well root that at the same time, which I'm not sure if it simplifies, because this doesn't look like a Pythagorean triple to me. Oh no, it is. All right. I guess they strategically chose this one. There we go. So we have 41. At the moment, it could still be an isosceles triangle. We're going to have to work out PC somehow. How are we going to work out PC? Well, P is on the back face of this cuboid. You can, if I try and imagine this is a cuboid, my board rubber, yeah? So you guys are looking at the cuboid. That's the front of the cuboid. P is on the back side here. P is on that back side. So there's the front. You can see the front of the cuboid. If I tilt it down, P is over here. And then C, so remember P is over here. C is over here, yeah? C is on the back side as well. So both P, yeah, over here, and C are on the back of the cuboid. Which means this line is at the back of the cuboid. It's here. There's P, there's C. We're going straight along. Straight along means we have another right-angled triangle here. So PCG is a right-angled triangle. It looks like this. PGC along the back face. GPC. And this is where working out that 28 was super helpful, because that's 28 and this is 20. Now we can work out PC by again doing Pythagoras. So PC squared is 28 plus 20 squared. And I'm just going to assume that it does give us a nice answer. Let's see. Nope. Hey, yo. 4 root 74. All right. Not ideal, but at least we know this is not an isosceles triangle. I mean, if it was isosceles, it would be much nicer. Okay, so with that, how do we work out theta? Well, we're going to have to use the cosine rule. Okay, we have 3 lengths and an angle. So I'm going to get rid of this so we can use the cosine rule now. Do you guys remember what the cosine rule is? Hopefully by now you do, because if you don't, it means you've not revised enough. Okay, cosine rule says it always starts off with Pythagoras' theorem. A squared is b squared plus c squared. Then we subtract 2 lots of b and c, cosine of a. However, we're trying to work out the angle, so we're going to do the rearranged version for cos a. We can find that really easily by making this positive. So we bring that here, and we minus the a squared, so we get 2bc cos a. Yeah, so the negative on the right is a positive on the left, equals b squared plus c squared. Then that positive a squared, when we move it over, we're going to minus a squared. And at the same time, we're going to divide by 2bc. So if you guys ever forget this rearranged version, you can rearrange it super easily. Okay? You only need to know this one. So in our case, the uppercase and lowercase a are the most important. There's your uppercase a, lowercase a is the opposite. B and c, doesn't matter which one you choose. So this could have been c, that could have been b. So it's saying cos of theta is b squared plus c squared. Now here, guys, you need to use a bracket. Otherwise, your calculator will square this and not the 4. Minus a squared. Did I not write squared on that? B squared plus c squared minus a squared all over 2bc. Okay? Now I'm just going to type that in just because if you are following along at home, you can type this in your calculator as well, guys. Make sure you are getting the same values as myself. Minus 41 squared. Whoops. I've completely messed up. Minus 41 squared all over 2 lots of 25 and 4 root 74. Root 74 is an interesting one because it looks like it could simplify, but it doesn't. Okay, I get 0.743 whatever. Dot, 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 dot. And then to work out cos, we're going to inverse. We're going to do the inverse cosine. Okay, which when I do inverse cos answer, I get 85.7-ish. Theta is approximately 85.7 degrees, and that's your solution. It's a pretty tough question, this one. It would be about 5 marks, though. I wouldn't say 6 for this, but yeah, 5 marks. So guys, 3D trig, always redraw your triangles. It's always just Pythagoras' theorem, and then sometimes a cheeky cosine sine rule as well. If you learned something today, I'd really appreciate if you hit that like button, subscribe for more maths content, and if you're interested in my GCSE courses, more details in the description, and feel free to join the Lung Gang Reddit page if you want to submit your own questions for a chance to feature on YouTube and TikTok. The link for that is in the description. See you in the next one. Nice.